Today, as 7th grade math students, I'm going to have you do some review of writing algebraic expressions. So this comes from lesson 3.6 in our Math and Focus Course B book. And again, we're writing algebraic expressions, which means I'm expecting to see some variables. And I'm expecting to see you simplify when possible. In fact, when you read the directions here, not only are we supposed to translate each verbal description into an algebraic expression, I also need to remember to simplify the expressions as much as I can. So I'm going to show you a few examples here in order. And again, you have a guest teacher today, and this is an opportunity to maybe do some checking. If you're feeling a little bit stuck, you've written something down, I hope, made an attempt, and I wouldn't necessarily erase or scribble it out. In fact, I would just maybe dig back in and maybe cross it out so we can see that you've changed your thinking and show us what you've now learned watching the video. So number one, it says sum of 1/2 t and 1/3 s. Well, I really want to go to my steps over here. I'm looking for some keywords first of all. So I see a keyword of sum. That's really a hint to me. We're talking about addition, and I hope that you have your notes out, our backwards words sheet, something to help yourself out and kind of remind yourself what these mean. So sum is talking about the result of an addition. So then it says I'm looking for the sum of 1/2. Well, that to me means 1/2 of something. And I'm looking for 1/2 of t and 1/3. That's pretty important. I can picture that as a fraction, 1/3 s. So let's go ahead and write what we have. The sum is really the result of something. So I'm even going to use these parentheses showing I need to find the result of these two things put together. So I'm expecting to see 1/2 t. Notice that variable needs to be next to my fraction here. Maybe in the numerator, but never in the denominator, because that would have a different meaning. And I remember here they said 1/3 s. Well, this is the sum. They're talking about addition, so here we've got an okay answer. But if you go back to our list over here, were there any backwards words to worry about? No. Distribution? Not this time. But let's talk about simplest form or format. Can I simplify anything? Well, there's no distribution here, and these are not like terms, so it looks as if simplest form has already presented itself. But let's talk about formatting. Are these in ABC order? Oh, A, B, C, D, S before T. A better way of writing this would be 1/3 S plus 1/2 T. This isn't bad. Oh, but I didn't give it a star yet. That means that there might be a more algebraic way of showing it. So 1/3 s is really like saying I have s split into 3 parts. It's kind of like saying s thirds. And this 1/2 of t is really taking that t and splitting it in half. You'll also notice that my variable t I'm being very careful about, making it look somewhat Danielian. It's got a tail here. There's a reason for that. I want to ensure that you can tell it's a variable and not an addition sign or something else confusing. This is the most algebraic answer we'd like to see today. And again, if you got stopped somewhere else before here, that's not all bad, but kind of pushing you today to see it in another way. All right, let's take a look at number 2. So switching gears here, it says I want 20 subtracted from 15/23 b. Oh, well, 20, that's a keyword. I'll underline it and tell you what it means. Subtracted from, ooh, I'm going to give this kind of a caution mark. In fact, my coding is telling you this is important. If you look back at your keyword sheet, you'll notice subtracted from are actually backwards words. So I'm just going to write BKW backwards, and it's backwards for subtraction. Well, let's see here that I have 15/23 b. If I'm going to write this backwards with subtraction, I know this is a subtraction problem, so I can show that subtraction. But starting at the back of the expression, first I need to start from the 15/23 b. And I need to take away 20. All right, I've done what they said. Backwards words are included. Not only did I find keywords, backwards words. Is there distribution? Nope. Simplest form looks like those are not like terms. There's nothing to be distributed or expanded. And let's talk about format. Do the variables come before the constants? The answer here would be yes. You also might want to check your fraction. Can you simplify 15/23? Well, not in this case. This is a final answer. Can't get much better than that. All right, let's move on. Number 3 says we're looking for the product of 5r and 7 divided by 15. Okay, we're using our steps over here. Are there any keywords? Yes, product. Product. If you look at your keyword sheet, you'll see that product stands for multiplication. And not only that, it's the result of a multiplication. So I might need some parentheses in here in a minute. I'm looking for the product of all of this. The 5r and the 7. I'm going to find a product of that. And then it says divided. Oh, divided by something. So I'm picturing that means I'm going to divide by 15. All right. There are no backwards words to consider on this one. So I'm really going to start with showing you the product. That really means I'm going to show you 5r times. And for those of you who have been using that x lately to mean multiplication, that will be marked wrong. So make sure you're using a dot, some symbol of multiplication that is safer than the evil x, which we save for algebra. So 5r times 7 would show me the product. And now it talks about taking that product. Product, again, is the result of multiplication. So I'm going to house that in parentheses. It says divided by 15. Oh, that doesn't look terribly algebraic. In fact, I can clean things up a little bit. So simplest form, there might be something I can do to simplify. Oh yeah, 7 groups of 5r gets me 35 r's. And that would still be divided by 15. Hey, we were able to get rid of the parentheses, weren't we? That's simplifying for sure. Now this doesn't look terribly algebraic. If we want to talk about this last step, checking for format, you know that we would turn that 35r into a numerator and that 15 as a denominator. Oh, this is great, but it's not a final answer because kind of have to revert back here to this idea of simplest form. Look at this fraction. Is there a common factor that goes into 35 and 15? Oh, in fact there is. They both divide by 5. So another good answer here, maybe a better answer, would be 7r over 3. This is probably the most algebraic answer. And now someone out there might say, no, hold up, Mrs. Schumann, I can write that as a mixed number. And in fact you can. 3 goes into 7 twice with 1 left over. So we would get 2 1/3 r. This is an okay answer. Yeah, it's okay. But let's be honest, a numerator over denominator, this m over n form that we've seen before when we first started Unit 1, this is really where we're going with algebra. So this is a more reliable answer, unless it's a word problem where they ask me, you know, how many pizzas or how many somethings are left over. Well, then I might need a mixed number just to make it more meaningful. But otherwise, this m over n is okay. This is a good spot to be. Is it also okay to have the r on the side of your fraction here? Absolutely. 7/3 r is really the same as 7r over 3. Has the exact same meaning. All right, let's look at another one. Number 4. Now this one's pretty exciting. We do need to take a look at it. If you notice here, it says I have a percent, 120%. That's not exactly a key word, but I do want to emphasize we're going to have to do something with this percent today. Okay, so if you didn't think to do that sooner, it's fine because you're going to make some changes now and you're learning as you go. I think the more you see different varieties of writing expressions, the easier it gets for you. And you're going to say, oh, I'm more familiar with the steps now. So 120% of, oh, that word of, I'm not sure if we catch that often, but in this case, they're really referring to of as a multiplication. So talking about groups of, oh, that's a multiplication, isn't it? So hopefully, if you don't have it on your keywords list, you're adding it now. Next, I'm looking for the sum. Oh, sum is that magic word, means addition again. And this of doesn't have to do with multiplication. Be careful because it's talking about the sum of. This really has to do with an addition. And sum is the result of something. So I'm going to put these things together. W and 1/12 U. Oh, I'm going to find the sum of those two things. All right, so I want 120% of, meaning multiplication. Do not use an x to multiply. Okay, that will just send Schumann through the roof. And she'll be back soon, so you don't want to see that. And I want to show you the sum. Well, that's something that needs to happen first. So I'm going to show you that with parentheses. I'm kind of trying to show you the importance of PEMDAS here. Sum means the result. So to get the result first, we have to use a grouping symbol. And sum meant addition. So I'm adding W to, actually I'm adding 1/12 U to W. Okay. Oh, hold up. I notice this multiplication here. And usually when there's a multiplication, it means we're not done simplifying. In fact, we're not in this case at all. In fact, this 120% really should be rewritten. In order for us to distribute it, it makes more sense to write it in decimal form. Well, I'm going to think off to the side here for a quick minute. If 120% really means 120 out of 100, oh, that's more than 100%, isn't it? How would I write that as a decimal? Look at this friendly denominator of 100. Oh, it would really be the same as something that lands in the hundredths place. Well, the last digit has to be the 0 of 120. The digit before that has to be the 2. So that 1 is really going to land out front. Oh, this makes sense to me. If we could cover up the last portion here and think for a quick minute, 1 whole pizza is like 100%. So if I have more than 1 whole pizza and some more, I could have 120%. We're going to use this to do a rewrite step. We're going to use this to show the factor that we're going to distribute is 1 2/10, 1.2. Notice I took the 0 off. If you don't like that, put it back on, but it works for me. And we still have to show the sum of W and 1/12 U. Still not done, but we definitely took care of the problem with our percent. In fact, we showed it as a decimal, and now we're ready to distribute. If you look back up at my steps, we definitely found keywords. There were not backwards words this time, but there is distribution. This is where we are, at distribution. So if I took 1 2/10 times W, I'm definitely going to get 1 2/10 W. But what's going to happen when you take 1 2/10 times 1/12? Well, that's weird to think about. Well, maybe I would show that somewhere else, and it looks like we might need some line paper for today's activity because I'm running out of room here. So 1 2/10 is really the same as 1 2/10 over 1, right? And I'm really distributing. I'm multiplying it here times 1/12. Times 1/12. So I'm thinking off to the side here what's going to happen. And that's 1/12 U, by the way. Oh, I noticed some cross-simplifying that could happen here. In fact, if you take a look at the 12 in the denominator and the 1 2/10 in the numerator, those look pretty similar, don't they? In fact, there's probably a way that I could rewrite this. Couldn't I turn that 1 2/10 into a whole number? Oh, can I multiply it by 10 on the top? And whatever you do to the top, you do to the bottom. At least you try. Here we go. Wouldn't this be the same as 12/10? Oh yeah, that was 12/10. It landed in the tens place. Times 1/12 U. Oh, this looks better already. I think I'm heading in the right direction, although I'm really running out of space. But I see some cross-simplifying without a doubt now. If you take a look at this, these 12 simplify. They both divide by 12, and you'll be left with 1 in the numerator, 1 in your denominator. And when you go ahead and multiply across, you're going to get 1 times 1 is 1. 10 times 1 is 10, and that U, that variable term, is still there. All right, here we go. Plus 1/10 U. Hey, this isn't too bad. This is a great answer, but it's not a final answer. I'm really running out of space here, and I'm trying to figure out what to do for you because I don't have an extend a page on this document. So I'm going to try to remember what I wrote. Wish me luck. So don't erase what you've done, but I'm going to try to get us a little more space. Oops, it's not going. There we go. This again has to do with this problem. So we are currently at 1.2, or 1 2/10 W, plus 1/10 U. I'm definitely hoping I didn't lose anything along the way. And we said this is an okay answer. This is why line paper might be your best friend. It definitely would be mine right now. This is not a final answer because if you notice, when I look back here, I was given a couple things to work with. One might be a decimal because I got that decimal from my percent. The other thing is a fraction. That 1/12 was a fraction. So which one can you give me back? Well, usually one or the other, not a combination. So another possibility is make them both decimals. This could be 1 2/10 W plus, how do we show 1/10? Oh, the 1 in the tens place, 1/10 U. This isn't bad. Not a final answer again. I know I see a lot of students like to erase. They like to rework this and try it 5 times. And then it's hard to tell what you've erased and what's still there. And I can't see your thinking along the way when you do that. So I would encourage you to keep on trying until you get into a final format. So what have I missed here? Why did I not say final answer? Oh, T-U-V-W. U comes before W in the alphabet. So when I go ahead and rewrite this, we need to see something like this if we're going to consider format in ABC order. This is the best answer I can think of algebraically with decimals. But hold up. What if you don't like decimals? What if you wanted to turn this into just fraction form? Well, I could go back over here and say 1.2 W is really the same as those 12/10 W we talked about a minute ago, plus 1/10 U. Oh, and not only will I want to rearrange the order and put the U's first, and I know that means U tenths, plus, well, this could be simplified, couldn't it? 2 goes into both, so I could get 6/5 W. If I wanted to go to fraction form, I'd say this is your best answer. Now there are lots of combinations along the way, but I'm looking for a lot of things. One of them being, is your fraction in simplest form? Is it written as m over n? Or if you're in decimal form, have you considered place value? And are you sure you have those variable terms labeled? Don't drop the variables. That's a common error I've been seeing lately. I'm going to take a look at number 5, and then I'm going to encourage you and maybe the guest teacher to take a pause and maybe dig in and make some changes if you need to on some other parts of this worksheet. So number 5, actually number 6 also has a percent, so I guess we'll do 2 more. Number 5, we're looking for keywords. These steps are still over here. They're reminding you first look for keywords. Well, 9/14, take it from word form, turn it into a fraction. That's what it sounds like to me. 9/14 of 6x. Oh, I want 9/14 of something. That's like groups of. That's a multiplication. And now I want 9/14 of 6x. Okay, that's already stated for me. And reduced by. Oh, what does that stand for? I'm not sure if that's in your keywords, but I hope you recognize it as being subtraction. Reduced by 10. I do not see backwards words, but I'm always thinking about that before I start writing my expression. And we're ready to roll. 9/14 of, we said, meant multiply, and 6x is given to me. And then it says reduced by 10. Oh, awesome. But you're not done yet. Whenever you see this multiplication, there's a big signal to you. This probably is not a final answer. There's something to be simplified. So we're sitting here in our rules. No distribution exactly, but we can simplify. So I'm going to write the 6x over 1, make it look like a fraction. And I see some cross-simplifying you might want to think about. And I didn't talk about it here, but notice I'm worried about the multiplication before the subtraction. And you might say, why? Well, because when I simplify, I'm using PEMDAS rules. So both of these numbers have a common factor of 2. 2 goes into 6x, 3x times, and half of 14 is 7. All right. So if I were to multiply and simplify just this portion, just the product here, 9 times 3x gets me 27x's, and 7 times 1 gets me 7, and at the back I'm still taking away 10. Well, let's consider a couple more things. Is there more simplifying to be done? Any like terms? Any other way of writing this? Not so much. What about format? ABC order, variables before constants? Yes, this is okay. In fact, this is a final answer. Notice I'm not worried about a mixed number here. I could probably write that as 3 6/7 x, but we don't need to do that unless we're maybe in word form and we need to be able to see how many wholes. This m over n is appropriate. All right, I said number 6 might be the final answer. The last one that we look at together before we dig into those tougher word problems on the next page. So number 6, 20%. Oh, we talked about percent. When I'm given a percent, I know it means out of 100. And I know that it's a good idea to work with this, maybe in decimal format. We've done that before in class, so I'm just taking you to something you've seen before. That'd be like 20 hundredths written in decimal form, 20 to the hundredths place. Okay. If I read on, 20% of something, there's that of meaning multiply again, and I want 1/2 of w, so I'll show you 1/2 of w, okay, somehow. I do not see backwards words, but I do see that I need to do some translation or some writing of an expression, so take that percent, we'll write it as a decimal, and I can take off that extra 0. I'm showing of something, so that really means multiply. I can show multiplication with a times symbol such as a star or an asterisk, or maybe even a dot, or maybe even parentheses. And I'm going to show you 1/2 w. Oh, awesome. This is going pretty well. That looks pretty simple. Although you notice that there's a multiplication sitting here, and that would really tell you that you're not done yet. There's something that we probably can do. We can simplify a little bit farther. So I looked at this. I could write this over 1. I noticed some common factors here. Do these both divide by 2? Yes. 2 goes into 2 one time, and 2 goes into 2/10. Be careful. Not 1 time, but 1/10 time. Okay? 2 times 1/10 would get us 2/10, so that works out. If I go ahead and multiply across, I'm going to get 0 1/10 w all over 1. Well, if you remember, any number written over 1 really will result in a whole number. So in this case, well, the numerator becomes my answer. And my pen wants to fight with me a little bit because I'm on video, of course. It's more fun that way. Looks like I get 0 1/10 w. This is a good answer. In fact, this could be a final answer. There are no leftover constants to deal with, so this looks pretty good. Now listen, when we started this problem, there was a fraction, that 1/2 in here, and also a decimal. That 20% became a decimal format. So I'll be honest with you, I would be okay if you also called this 1/10 W. But if you do, it might be better to call it W/10ths. Ah, this is another strong answer, algebraically speaking. So this one in the middle, yeah, it's okay, I don't mind it. But be thinking about maybe this decimal form or maybe this fraction form as a final answer. And it's kind of flexible again because we're given that 20%, which we typically would turn into a decimal format. So I would be flexible on either of these answers. All right, I'm going to trust that this is a good introduction to a lot of the other problems that you're seeing in here. They probably do get a little bit more complex, but this would be a great time for our guest teacher to maybe call a timeout and let you return to your partner work. See if you can make some changes. Anything that you would fix up after we talked, anything that you want to make sure you write in simplest form, get rid of those multiplications when you can, or watch that format, see if you can maybe get those variables before the constants, consider ABC order, consider turning it back into subtraction when you see that special combination of adding the opposite. So many things to consider when we're talking about expressions. And we're going to apply these steps to equations very soon. So with that, again, we'll stop the video. This will be part 1 for your expression writing. And in a little bit, maybe you'll check into the harder, more challenging problems on the next page.